Hello everyone, and today we're going to be looking at something that's a little bit more complicated than what we did yesterday. We're going to be trying to find x-intercepts still, but instead of trying to find x-intercepts when things work out well, we're going to be looking at situations where it doesn't work out so well. So everything was kind of cooked in a way yesterday so that it was quite easy to find the x-intercepts. So first we'll just review how you get x-intercepts when you are able to find things quite easily. So to find the x-intercepts, the first thing you want to do is you want to factor the expression in order to change it from standard form. So change it from standard form here into factored form. So I put an example here of how to do that. The first thing you need to do is factor out the common factor, okay? Or, just you need to take this out anyway because you have an a there in front of the brackets, so you really don't have a choice. That has to come out. Okay, so we factor that out. We're left with x squared plus x minus 6. Now we can factor this expression here by looking for two numbers that multiply together to give you minus 6. That term comes from right here, and adds together to give you plus 1, and that comes from right there. So you can see it's plus 1x. Well, what two numbers make that work? Well, plus 3 and minus 2. So then you get an expression that looks like this in factored form, and that tells us what the x-intercepts have to be. Remembering that it's always the opposite of what you see sign-wise inside the bracket. So we're going to get minus 3. Don't need the bracket there. Minus 3 and plus 2. So that's what you do when things work out quite well and the expression's factorable. Well, what if it's not factorable? So taking a look at this expression here, we're looking for two numbers that multiply together to give us plus 1 and add together to give us plus 4. Well, the only things that with integers that work to make plus 1 is 1 times 1. And 1 times 1 gives us 1 and 1. When you add those together, you get 2. And so this doesn't work, and you're not able to factor this expression over the integers. And so now we have to find some other way. So one thing you could do is you could just let y equals 0. And get 0 equals x squared plus 4x plus 1. And you could try to solve that expression, except for we don't really have the tools to do that. So maybe you think, okay, well, I'll factor x out of here. I get x plus 4 plus 1. And again, that's not a super easy expression to solve. And so we're kind of stuck. So what I would suggest doing with the level of knowledge we have right now is you would just graph this. Okay, you try to graph it. And so if you completed the square, you would get the vertex. And then you could graph it, and then you could just try to read the x-intercepts off the graph. Now the problem is you're not going to get a very precise answer because the x-intercepts, when you graph it, which I've done on Desmos here, are actually minus 3.732 and minus 0.268. So it's unlikely you'll be able to get that precision from your hand graph. So we need to develop a different way. So let's just talk about x-intercepts in general. To get an x-intercept in general, you do what we tried to do, which is let y equals 0. Okay? So let's just do this in general. So we have an expression y equals x squared, or let's even be more general than that, ax squared plus bx plus c, and we're going to let y equal 0. So 0 equals ax squared plus bx plus c. Now this, you can solve this. Even with just the letters in here, you can solve this. But you have to be clever about it. If you think about what form of the quadratic you could solve with, let's just look at a different form, y equals a x minus h squared plus k. If you had it in vertex form, then you could subtract, well, first of all, we'd have to let y equal 0. That's k. And then we could subtract k from both sides. I'm going to do this quick. divide both sides by a. You're going to get something that looks like this. Okay? Now, the next step people find confusing because they're used to doing this. X squared equals 4, so x equals 2. That's not actually right. Okay? What two different numbers that when you square them give you 4? Well, x could be either plus or minus 2, since minus 2 squared is also 4. So when we take the square root of something, we need to do plus or minus that. Okay, so that's what we would have. And if we add h to both sides, then we would get our answer that x is equal to h plus or minus the square root of k over a. Okay, so it is possible to solve, but we would have to go through the trouble of getting this form all the way over to that form. And that is difficult. In fact, I have it here. Okay, so I've written it out in its entirety, and you can study it in detail when you want to, but let me just run through it a little bit simply, is that we're trying to complete the square on the general form in standard form, okay, of a parabola. So we're just completing the square on this. So we're just going to do all those things that we do to complete squares when we have numbers. Just now we're not going to have numbers, we're just going to work with the letters. So the first thing is you have to factor out the number that appears there. So when you factor out a, you're left with x squared, and b over a, because a times b over a would give you back b. And remember, we're allowed to have this number here. Okay, now I'm just going to simplify this by subtracting c from both sides and then dividing both sides by a. And we're left with that. Now I need to complete the square. So what do I do? Well, I take half of this part and then square it. So there's half of it, and it's squared. I end up with b squared over 4a squared, which becomes my tach-on number. So that's why I put this over here. But we also know that we can't just add things on, we have to take them away too. Because when we do that, we effectively do nothing and everything's okay. We don't change the value of the equation. Okay, so now we know that this is a perfect square trinomial because I made that choice specifically by taking half and squaring it. Okay? Now, take the square root of this term here and the square root of that term there, and you've factored that by our shortcut method. Now, add both sides, add this to both sides, which gets rid of it on this side, and we get it on the other side. Now, you have to put this together to form something that has a common denominator. So you have to multiply the top and the bottom by 4a on the right here, which gives you 4a squared, and on the top, 4ac. Now, add the fractions. You get this. Take the square root, because we have a square here. That's why we have our plus and minus, like we talked about a moment ago. Take away b over 2a from both sides. You end up with this expression over here. Okay? Now what I'm going to do is I'm just going to take the square root of the top and the bottom here. So I take the square root of the bottom, I get 2a. And I can't really take the square root of the top. I have to leave it as an expression. Can't simplify it any further. And then I have a common denominator here and here. And so when I put them together, I get this. This is called the quadratic formula. And you have to know how to use that. And you have to know that it comes from completing the square. But you won't have to replicate this process on a test or an exam. Okay, so now let's go back to this expression here. We're going to use this once, and then you'll get lots of practice over the course of the next few days. I'm just going to write out the quadratic equation, and a lot of times people ask me, do I need to memorize this? The answer is yes. And the reason for that is everyone that does math knows this expression. Okay? They know this equation. This is just one of those things you know. So you have to memorize it. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Every math person knows that, and I want you to be math people, so I need you to memorize that. Okay, so let's identify what the variables are. Okay, so a equals 1, b equals 4, and c equals 1. Notice that the a is always attached to the x squared, the b is always attached to the x, and the c is always the number on the end. It doesn't matter what order these are written in. If this was written first, b would still be 4. That's something people have trouble with. Okay, now all we do is we take these and we plug it in there. And this is actually pretty straightforward to use. It's just people get confused in where it comes from. So the x-intercepts now, okay, are equal to minus 4 plus or minus the square root of 4 squared minus 4 times 1 times 1 all over 2 times 1. Okay, and all I did was I plugged in these values. So you can kind of see, if you follow along, that the b went in there and there, because there's a b here and there's a b there. The a went down there, because there's an a down there. And the a went in here, because there's an a right there. And the c went there, because there's a c right there. Okay? So let's go back and let's solve this now. So this is equal to minus 4 plus or minus the square root of 16 minus 4 all over 2, which is equal to minus 4 plus or minus the square root of 12 all over 2. Okay, and that allows you to write out both of the answers precisely as what they are. So the two x-intercepts here are equal to minus 4 plus the square root of 12 over 2, and minus 4 minus the square root of 12 over 2. And you can actually leave them like that in most cases. If you're doing a word problem where you have to identify a numerical value, money, time, something, you would never tell someone that, you know, you have minus 4 plus the square root of 12 over $2. So you would have to put it as a decimal. Okay, if you do that, and it's a useful exercise to evaluate these things, you'll find that it gives us exactly the same two x-intercepts that we had originally.